this tutorial, we're going to look at how to do survey data analysis within STATA. So unfortunately, I couldn't come up with a real data example for this survey data example for the following reason. When you're learning about analyzing survey data in STATA, you want to look at a bunch of different examples. So in this tutorial, we're going to cover simple random sampling, stratified sampling, cluster sampling, and then even look at a more complicated, a stratified cluster sample. But to do all of these things within STATA, we just need a nice, neat data set to look at. So what we did here is came up with our own data set for a country called Inventia. So I made this up. Essentially what we did here is we came up with a country with 4 different provinces, and then within provinces you've got multiple different districts. So you've got the country divided into 4, and then within each province you've got a bunch of different districts. Now we're interested in estimating the prevalence of malaria, and the way this data set's been designed, within each of these 4 provinces they have different climates such that we expect some province-level variation in our estimate of P. Additionally, access to malaria prevention may be different between these districts, so we would also expect some variability in P by district. So we need to think about the fact that P is going to vary within province, within district, and we want to come up with a survey where we can estimate P in the entire population using each of these survey designs. We'll look at these examples specifically in practice. So anytime you're analyzing survey data in STATA, the key thing is to know how to survey set your data. So in order to do that, you just run this one survey set command in STATA that we're going to see later. But before running it, essentially what you're feeding into STATA with this survey set command is you're telling STATA first, what is the design of my survey? How did I go about doing my sampling scheme? And then second, you're going to tell STATA, do I want to use a finite population correction? At which stage of the survey design? And then third, and arguably most importantly, you have to, first of all, feed the survey weights into STATA, and then within this survey set command, you need to tell STATA what your survey weights are. So once you've established those 3 things in STATA and run your survey set command, then you can do most analyses in STATA just by first saying survey, SVY, and running your command. So let's go ahead and open up STATA and look at an example. I think it'll become more clear once you see it within STATA. The first example we're going to look at in STATA is simple random sampling. So go ahead and open up the srs.dta dataset. Now throughout this class, we've made a lot of random sampling assumptions, but the survey lecture sort of formalizes this idea of random sampling. So really, if we want to make interest about a general population, what we've really been assuming so far is that we have some random sample from this population. Now in this example, what we're going to assume is that we have a population of size 500,000. That's the population of Inventia. Then I'm going to go into that country and I'm going to randomly sample 1,000 individuals, just at random. And from those 1,000 individuals, I want to try to estimate P, the prevalence of malaria. So we went through that list of things that we needed to tell STATA in our survey design. The first thing we need to think about are what should our survey weights be in this scenario. So the probability of any given individual in Inventia being included in this survey, since it's a simple random sample, that probability is just 1,000 divided by 500,000. And let's just call this guy Q. That's just a random letter I thought of. And we know that the survey weights are defined as 1 over the probability of inclusion, or 500,000 divided by 100. So these are the survey weights. So if I wanted to construct survey weights within STATA, I would need to say generate weight SRS is equal to, remember it's my population size, divided by the number of people in my sample, which is 1,000. Next, in this example, let's say I am going to use the finite population correction. We saw in class that this is a correction in surveys that takes into account the fact that we're sampling from a finite population. Generally, the assumption you make in statistics is that you have an infinite population, but in this example, we know that we're just trying to make inference about a population of size 500,000. So we can use this correction to allow us to get more precise inference. Now, there's some controversy in statistics as to whether or not you would want to use the finite population corrections in practical examples, So if you're doing a data analysis, go ahead and read up on the finite population correction before you just decide to use it. But I just want to show you how you would do it in STATA. So remember before we had n, which is the total population size, and small n, which is our sample size. The finite population correction f, it's technically defined as 1 minus small n over big N. So this is the definition that we saw in class. This is the finite population correction. That's not what STATA wants, though. This is one of the subtleties of STATA that I don't quite understand why they defined it this way. But when you're doing this analysis in STATA, what you're going to want to feed into STATA is the finite population correction. It's actually in STATA just equal to small n over big N. So don't get confused. Don't plug in 1 minus n over n. You want to plug in only small n over big N. So we can generate an FPC in STATA as well. All right, so at this point, we've got our weights. We've got our finite population correction. And third, we know our design. Remember, it's just a simple random sample. So once we have all of these things, what do? We survey set. So to learn more about the syntax of the survey set command, you can just type in help survey set. And it tells you all about this command. At the bottom, they have many useful examples of how to run this command. I'm going to work through just a couple examples to illustrate the basic concepts. For a simple random sample, we need to say survey set, and then the first thing you're going to specify is the ID of the participants in the survey. So you need a unique identifier for each individual. So it's going to be ID is the name of that variable in my data set. And then you're going to create brackets. And within those brackets, you're going to specify P weight. Those are your survey weights. And in our example, we define those as weight underscore SRS. And the last thing we're going to do, if you decide to use the finite population correction, you would say comma FPC, and then in parentheses, put the name of the variable that contains your finite population correction. In this example, it's just FPC. And hit enter. And then STATA tells you this information. It says, okay, I've got your design read in. I've decided that we have these survey weights. It tells me how it's going to estimate my variance. You can change that if you want. Gives you all sorts of information about your survey design. And once you've done that, remember we can run any commands if we say survey : not any commands. There's some commands that don't work with survey, but a lot of commands do. So I'm going to say survey proportion malaria, because malaria is the covariate in my data set that contains a 0-1 indicator for whether or not an individual has malaria. And hit enter. So doing this, I found an estimate of 12.8% prevalence with a confidence interval from 10.7 to about 14.9. Now let's go back and let's take the finite population correction out and see how that changes our estimate. So I'm going to survey set, but without specifying a finite population correction. And then I'm going to run the proportion command again. So what do we notice? We get the exact same estimate of malaria prevalence, 12.8, and now let's compare our confidence intervals. Now what you're going to notice is that when we do not use the finite population correction, we actually end up with a very slightly wider confidence interval. So in general, if you take into account the fact that you're sampling from a finite population, your confidence intervals get narrower. Now let's say that I ran the proportion command without specifying my survey design. What do you think is going to happen when I do that? If you guessed that you would get exactly the same estimate as the previous that we saw, you would be correct. So this is really interesting, right? Well, maybe. So the first estimate that we saw when we specified the survey design in STATA, we said it's a simple random sample, but I don't want to use the finite population correction. We got an identical confidence interval to when we didn't specify the survey design at all in STATA. And this should make a lot of sense, right? When you're analyzing data, typically you assume that your data comes from a simple random sample, and typically you don't make any finite population correction assumptions. So it makes a lot of sense that we would get the exact same results when we tell STATA we have a simple random sample and we don't want to use a finite population correction, and when we just do an analysis without specifying anything about the way our data was obtained. All right, the last thing I want to do is go back to the example where we specified a finite population correction. Go ahead and survey set your data with the finite population correction and run the survey proportion command. Now, once I've run a command in STATA, it actually stores some things internally within STATA that might be interesting to you, and you can extract those from STATA if you know how. And I'm just going to show you how to extract one quantity, which is called the design effect. And what the design effect is, it's the ratio of the variance under your current survey design as compared to the ratio of the variance that you would get under a simple random sample with an infinitely large population. So it's some crude notation, but the basic idea is that it's the ratio of the variance for your design over the ratio of the variance for if the data was collected from a simple random sample with an infinite population size. This is a useful quantity that pops up a lot, and if you do a survey, you're going to want to represent this quantity. So once you've survey set your data in STATA, it keeps that design in its memory, and until you specify a new design, if you run survey : it's going to use that design to calculate whatever quantity you want. So again, run survey proportion malaria. When you run this command, STATA actually stores internally some interesting quantities that you might want to extract from STATA for your own use. One of those quantities is the design effect. And the design effect is equal to the variance of a quantity, in this case it would be the prevalence of malaria, using your survey design, divided by the variance under simple random sampling. So essentially the design effect is a measure of how efficient your survey sampling design is relative to simple random sampling. To extract that quantity, we would type in estat effects, comma, def. And we see it gives us the estimate of the proportion again, the standard error, and in this last column it gives us the design effect. And in this case it tells us that the design effect is equal to 1. That makes a lot of sense though, right? Because we have data from a simple random sample. STATA knows that because we told it that by specifying our weights, our FPC, and our design in survey set. So it's saying that the ratio of our design relative to a simple random sample is 1 because our design is a simple random sample. The last command that I want to look at is learning how to estimate quantities within subpopulations. In order to do that, what you would do is you're going to type survey sub and then tell STATA exactly what subpopulation you want to estimate the prevalence of malaria with respect to within these parentheses. In this case, we're going to obtain province-level estimates of malaria prevalence. So first, I'm going to say my subpopulation is if province equals 1. And so I say survey, comma, subpopulation if province equals 1, and colon, and then I just run whatever command I want to run. So I'm going to say proportion malaria, and hit enter. And you can see up here we have 1,000 observations, but there's only 450 observations within this subpopulation, and only one strata. And we can see the prevalence in province 1 is equal to about 12%. We can repeat this command for the remaining provinces. The estimate of the prevalence in province 2 is a bit higher. It's around 0.13. And again, slightly higher in province 3. We have a lower population size, or a lower sample size in province 3 at 180. And finally, in province 4, this would be a province that has the more arid climate, less malaria in this province. We see now the prevalence is only about 4%, and there's a smaller population size in this district, which also leads to a smaller sample size. since we use simple random sampling, we would expect to have fewer people from the smaller districts. So in this data set, there does appear to be some province-level variation in malaria prevalence, specifically between Province 4 and the rest of the districts. But this is just also showing you illustrating for you how to estimate quantities from survey data when you want to look at subpopulations.